Hello hires, we are going to take a slightly different tact for some of this week and want to do a little bit of work on materials, and we might get to manufacturing next week depending on how long we keep going with this. So when we talk about materials, it's one of the ones at the start of the course where it's not the driest topic for me, but it's one which means we've got the most information to try and remember. But it's not about remembering, it's about using the sheets which we provide when you get back to school. It's about using the information that's there. You don't have to remember everything. So we give you worksheets out which have all the details about the materials and stuff. You just need to keep referring back to them. The only time you have to remember it is in the exam. Now, by the time we get to the exam, your materials knowledge should be good enough that you should be able to tell me the most of the materials that are going to be required. In the exam, one or two materials will answer the majority of the questions. So you don't have to have a total blanket of every single material, but it's handy to know all the different names in case it pops up so you can identify it and say what it is. So thinking about that going forward, this is one of the most important parts. It's the memory part. It's required for your folio. And the list I'm going to give you is just the ones which are in the course assessment specification, the one you can go back and look at. We'll use that as the basis. But there are so many more materials out there that I'd like you to use, and I've got books on that when we get back in the classroom, and we'll talk about that when we get there. See, before we get to actually looking at materials itself, though, we need to understand why we're choosing a material, or what are the benefits or disadvantages of certain materials, and that's what I'm going to do just now in a very, very short introduction to materials here. So we have a slide set here. I think these are Miss Blair's ones, so I'm just going to run through some of the ones in here. Maybe got some stuff in there which I might not use or do a different way, but look, they're still totally relevant. I'm going to use them. I'm quite happy using them. Okay, so what we're trying to do is trying to get this ability to say why we're using materials, the choice of them in terms of their impact on environment and society. This will become quite important, this bit here. Okay, we need to understand that comes up in a lot of subjects these days, not just maths subject. Okay, technical suitability, saying why we're actually selecting material and the reasons for actually selecting it. Okay, so when we think about materials which are suitable for products, and I'm talking about products that go all the way from desks, chairs, shelters, bus shelters, bike shelters, picnic benches, that there's loads of things that they can do, displays in shops, all this sort of stuff. You know what, I actually think that could be this year's one, is possibly a display in a shop, when we come to the folio, because we've been through a few other bits and pieces. Maybe it might even be something, a seating solution, but a little bit of that could be something for kids. But this is where it becomes important. What materials are we going to use and why are we using them? Some of the questions we should be asking ourselves is, can we get a hold of the material itself very, very quickly? Can we go along and buy it from a wholesaler and they have it in stock? We're not sitting waiting for weeks and weeks and weeks. Call that the lead time. So the lead time is quite important when we're thinking about stuff. Having come from a manufacturing background, I know that the lead time where we worked was all based on something called just-in-time. Now, just-in-time is where you have your suppliers only delivering the materials just as you need them. So a week before we needed them, the supplier would deliver some stuff. Sometimes not even a week, sometimes it's a couple of days. But you don't have to hold them. They have to hold them, and it's for accounting purposes and things. It's all to do with monies and stuff. I'll explain that. There's a whole lesson on that later on. But is it readily? You don't want to have to say to someone, and you've got a customer who wants something in 3 weeks, and you go to your supplier and he says, it's 8 weeks before I can get hold of that. That's not going to work. So you have to think about materials that you can get to hand. The most important thing about materials are their properties, and what do they actually possess. What are the reasons for choosing them? What is their properties? And you'll see that when we go through some keywords, you'll say, I understand what properties is. That'll be easy to understand. So I need you to just know what the properties are, and then actually use those properties to justify why you might use something and why not. Environmental impact, I did say that will become quite important. So again, we've got questions which are geared towards that. And thinking about these days, it's not just about saying, well, let's just make it out of wood because wood's easy to get hold of, and yes it is, but what's the environmental impact? Where is the wood coming from? How far is it travelling to get here? What's happened once the trees are cut down? That's environmental impact. And that same goes for metals and more so plastics. So I gave you a quick thing there about readily available, so we'll talk about that more again when we get them back in class, but also things that we think about are standard lengths and sizes. So things come as pre-cut, they don't come as you want them, you will have to process them a little bit as you get them in from the shop. So think about Dad going down, want to do some decking out in the back garden, he'll go down to the wood supplier, the timber merchant, he'll order the stuff up, but unless the timber merchant's very nice, you'll have to get it all back and then cut it to size, or you'll have to pay someone to cut it at the timber merchants because they come in a standard size. That way they can sell what they need. They don't have to have multiple piles of stuff, you know, that some people might buy, some people might not, you know, you can't wait on things like that. So standard lengths and sizes are what comes in, and this is what we use to calculate prices. It helps us work out what we're needing in terms of material waste and things like this as well, and that does actually come into your folio, working out specific sizes of stuff. When we talk about standard components are things which we use commonly all the way through different products. So different manufacturers will use exactly the same standard components, and the picture's a giveaway: nuts, bolts, screws, nails, brackets, fixtures, anything which we can buy from someone else. As a manufacturer of toasters, say, I do not want to be making nuts, bolts, screws, anything like that. I want to buy them in because they are lower cost, I can guarantee the quality coming in, they're easy to get a hold of. For customers, they're easy to replace, you know, they can go out and get them out of the shops. So standard components are just things which are commonly used. It's there to save money. You buy it in bulk. By buying in bulk, you reduce the overall cost of individual parts. So if you go to B&Q, you might pay £6 for 6 of these nuts and bolts here. If I go to one of my suppliers, well, used to call them ironmongers. If we go to the ironmonger, then I might be able to get 15, 20, 100 of them for the same price as what I get from B&Q. That's the difference in terms of actual supplying cost. So we mentioned environmental impact there. So these are the things that we're going to be thinking about. Is the material suitable for its use? So is it going to last? How reliable is it going to be? Do I have to do anything to keep it going? So things like this, we were thinking about metals rusting. We are thinking about things that are exposed to water. Sunlight will actually degrade your material depending on what it is and where it's being used. Is it sustainable or renewable? So can you recycle it? Has it come from recycled stuff? Is stuff being replanted quickly to replace it? You know, are we thinking about it? Metals, recycling, things like that as well. So again, these are quite important here, things to think about as we go through the course. So the main thing, if we were sitting in class, I would get you to go away and I would get you to get yourself a definition of each of these key words. So strength, ductility, hardness. I'll let you read through them as I'm talking away here. The reason for these words, they describe how a material reacts under certain circumstances, and each of those definitions are meaningful when you are choosing something, when you're choosing a material for a purpose. So strength is going to be one of the main things. Obviously, if I'm going to be designing and building a bridge, then strength is going to be one of the main aspects here. It needs to withhold whatever weight is underneath it, so we're thinking about how that material reacts to the forces which are applied to it. Now, you could talk to a bridge about that, but anything which supports a weight, so even a chair would be supporting a weight. So the strength of some of the components in there is going to be important. And as we go through each of these keywords here, and you can look through them, you see the definition of what it actually means in relation to that material. So these keywords may well pop up during some of your answers and during some of the folio work that we'll do. Okay, so I would expect you to go away, read these up and have an understanding of the definition. Okay, I'm not going to go over every single one of them and talk about every single one of them for you just now. Now, Miss Blair's broke this down a little bit more into individual metals and plastics. So generally, when we talk about conductivity, we talk about something conducting electricity is the main one. But I also like to think about conductivity as conducting heat, conducting light, conducting sound. These things also come into play when you're talking about your designs as well. Metals are particularly prone to corrosion. So corrosion can happen in a number of different ways. There is no metal which is absolutely devoid of any corrosion. At some point they will do, at some point, just some do it a lot faster than others, and some a lot slower. So like the steel, if you take steel, you place it outside, within a few years it'll have rusted away. If I take copper, same situation. Copper oxidizes, so it gives a little bit of protection, so it lasts a lot longer. You're talking multiple years longer. So copper's very good for using outdoors, as is things like lead, so they just don't degrade in the same way. We're talking thousands of years to do it, but they still have some sort of corrosion in terms of their metals. We talk about their strength, one of them being tensile, but also we talk about compression, torsion and shear. So different ways in which you are using the product and how it might react. Melting points might affect something depending on what you're doing. We'll come to that one, we'll leave that one just now. Plastics are slightly different. We think about density. Density is weight in relation to the size and volume. The way we measure density is we take 1 cubic centimetre of the material and then we weigh that, and that gives us a density of that. So if I had 1 cubic centimetre of aluminium, you'd think that's nice and light. If I take similarly 1 cubic centimetre of gold, there is a significant difference between the two weights of the material. And I mean significant. And again, I can show you that in the classroom where we have things like lead, which is quite light, and we have other steels which are extremely heavy. Plastics will shrink. Again, it depends on where it's being used. Sometimes even in the sunlight it will shrink. Heat obviously will shrink plastics, and we'll see that when we go into the workshop and have a little play around. So heat and shrinkage, also we have to think about that when we're using plastics. Transparency, plasticity and lubricity, they are all things which we will think about as you're going forward. So depending on what you're doing, what your product is, you may apply some of these properties to those products. So that's our quick little rundown through. So we've got materials, we've got properties, and a little bit about impact. So that's just a very quick introduction to that. So what I'm going to do, I think I'll just keep this all in the one video. The only thing I want us to do just now is to think about wood and how we use woods. So the ones which I'm going to direct you to are ones which are in the course assessment specification. So I'll give you a little list of woods, and then I'm going to give you a little quiz so you can get some practice on that as well. So wood is it's natural, we know that, it comes from trees, but I'll tell you what, sometimes ask a practical wood class, where does wood come from, or you ask first years, where does wood come from, and it comes from timber. Timber's just another name for wood. So yes, it comes from trees. Okay, so each wood, different woods have different looks, there are different characteristics to them, the different ways that we work with them. Some are easy to work with, some are not. Some are hard wearing, some are not. Some will last away. Some we have to do things to make them longer lasting. And generally, most wood can be environmentally friendly. It depends on how we're actually using it. So disadvantage of woods. When we talk about woods, we generally talk about 3 different sets: hardwoods, softwoods and man-made. Hardwoods are the ones which tend to come from the tropics. So anywhere where the country is nice and warm. They are very slow growing, they are very expensive, but they are very durable, they're very hard wearing. The closest you'll get to hardwood here that you might see in use, in fact round about the school or that, you will see some beech trees, you will certainly see some oak, and you might even see some chestnut, so conkers, that's a hardwood. Big broad leaves, but they're very good, very hard wearing. Cherry trees, apple trees, these are all still hardwoods as well. Generally they don't grow that big and we don't tend to use those as much. You might get a bit of cherry, so you might see some of that around, but again, you can use that in your investigations. If we are cutting things down, such as in Brazil where we do deforestation and they're continuing with that there, they cut it down, not so much for the value of the wood these days, but because they want the land for agriculture. But deforestation, we have to think about, for cutting trees down, we need to get them from a sustainable source and then replace them. So that's the key thinking, talking about sustainability with woods, especially the hardwoods. In Scotland, we see mostly softwoods, and I'll come to that one just in a wee second. Wood, yep, can come in. The problem with wood is that we don't get really big pieces of natural wood. Okay, generally in the workshop we've got about 150mm, as much as we can afford. To get any wider than that costs a lot more money, and you need to get to different trees, which obviously have to grow longer to get to that size, and you get problems with them as well. So to get round that, we sort of build up larger sections by laminating wood together, join it together to make larger sizes. Woods, yep, some of the boys in here, they'll tell you woods can warp, altering their shape, making them harder to work with. So most definitely, when you came to make some of the practical wood projects, it's fine at the start. You go to assemble it, you come back a week later, instead of a flat piece of wood, you've got something which is like rocks onto the desk, and it just moves back and forward, so it's not great. So the softwoods, I said I'd come back to that. The softwoods, so the hardwoods that we just talked about there are slow grown, around about 100 years to mature. Softwoods about 30 years. Manufactured boards, that's our third one, which is actually made, it's a composite which is made up of various parts of wood and then glued together, which gives you the option. We'll come to that in a wee second. So I'm not going to go over, we've just done sort of the hardwoods here, which is the big broad leaves. Our softwoods come from our needles, and this is where we get our Scottish stuff from, is that we have an abundance here of pine trees. So if you look across the Forth, anywhere around about, big green swaths of trees is generally grown for a reason. They grow quickly, they get mature, they get harvested and they get replanted. We use the wood locally for different things. So it can be furniture, sometimes it can just be for as a heat source these days. The advantages, I'll let you read through. We're just going through things like how they look, how they're easy to work with. I think we covered that up in the other slide up the top up there. And again, that's just covering the same parts here. I've just got a duplication of slides in there. Or is it just me? Let's not worry about that. Okay, so I did say about the wood changing, so this is what it can do if you leave it: bows, crooks, kinks, cups, twists. It does all this if you don't actually use it fairly quickly, or if you don't prepare it, but you don't need to worry too much about that. I'm going to skip this bit here. The one I want to do, I want to look at some of the woods. So our softwoods, this is fast growing, less than 30 years, relatively cheap, easy to sustain, grow quickly, renew them. So the key words: Scots pine, red pine, spruce and cedar. These are the key ones that we want to actually think about. This is what we tend to use in the workshop. It tends to be what you go around buying in the shops, your fascia in your living rooms, skirting boards, all this sort of stuff. So low cost, easy to get, lots of it around, and it's fairly quick to grow, so we can make it sustainable. These are our properties and our uses. So you see how the commonality between a lot of the uses here, and again it gives you a little bit of definition here. So again, this is a table that I want you to remember. When we go to the hardwoods, slow grown, generally more attractive, which they are, textures, colours, greater durability, last longer, easier to work with, some of them, much nicer to work with. Again, we still want to be planting, so again it's one of these ones where, but it takes years to actually get the wood back grown again, so it's a much harder to get commercial manufacture of these. These are the key ones: oak, mahogany, ash, beech and teak. So again, these are the ones which I'd like you to kind of remember just now. And again, I've got my nice little table here, and again the little pound sign relates to the cost. So you can see hardwoods are significantly more expensive than softwoods, but look at the uses: mostly high quality stuff, things which are going to be used on a regular basis, and I'll get you to think about that as you go round about your houses. Okay, we'll leave it at that just now. So hardwoods, these are two tables I want you to look at: hardwoods, and softwoods, and I'm going to ask you some questions on them. I'm going to ask you some questions about forms possibly. I'm going to ask you some questions about what happens with the wood. I'm going to ask you some questions about advantages, disadvantages. So that'll come as a little Google form quiz, so I'm not going to make it lots of long answers, it's just going to be kind of multiple choice answers, and we'll get you doing some of this stuff here. This is important, this is the mainstay of the course, materials. Okay, so first thing we're going to do is just cover some woods for you, and it shouldn't take too long to use the tables to answer the questions. That will get you used to understanding everything. Okay, right, okay, speak to you later in the week.